nanohub.org.
Online simulation and more for nanotechnology.
All right, let's get started. Good morning and welcome to Purdue University. You are here for the Grand Challenges in Resilience workshop, but you probably already know that by now. We are here at the Purdue Recreational Sports Center, a rather unconventional venue for having a technical session. But I was told that if the talks get really boring, then the basketball hoops are going to come down, and that should keep you entertained. So that's the plan behind having it here. So this is a workshop which is funded by jointly by NSF and by various colleges and the Vice President of Research Office here at Purdue University. And it's being organized by our center, which is the Center for Resilient Infrastructures, Systems and Processes. So this workshop has three themes. There is resilience in cyber systems, resilience in cyber physical systems, and resilience in socio-technical systems. And the term resilience has bandied about quite a bit. So, of course, when you want to start a center in resilience, you want to have an authoritative definition of what resilience means. So, from now on and forever, this is the definition of resilience. It has two aspects to it. One aspect is the preventative aspect. So this is where you design your systems so that it will be able to prepare for changing conditions and be able to adapt to changing conditions. And the second aspect of the definition is the reactive aspect of it, whereby if bad things do happen, disruptions happen either because of deliberate malfeasance or because of natural errors, your system is able to bounce back quickly, is able to recover quickly from it. So the goals of the workshop, there are 4 goals. The first one is to document what is the state of the art and state of the practice in resilient system design. The second one is to put the technical contributions in the context of the technological changes that are happening and to identify which are the topic areas where we think resilience is most critically needed. The third one is to lay out the medium-term and the long-term research as well as translational challenges to make our systems resilient. And the fourth one is this brings together 3 somewhat distinct communities, and we want to see what are the lessons that are common across these 3 communities and what are some of the domain-specific ideas that are there. And broadly put, the communities are represented by NSF's CISE and CMMI communities in here, in terms of the cyber physical, and the socio-technical themes. So those are sort of the high-level motherhood apple pie goals. Then there are lots of nuts and bolts goals, which is where you will all get involved in doing some of the grunt work, and hopefully we'll have some fairly influential papers come out of this. So we will write a workshop report which will be meant for the technical communities as well as the funding organizations. Then we will be writing 3 vision articles based on the discussions in here, and this is where you've already gotten some homework, and now this has become classwork, since I expect some of you will be doing that here, where you provide your thoughts on a few questions, and those will be used to seed these vision articles. We'll have all of the sessions being recorded, and all of the presentations will be available on the website. So this will serve as a portal with a ready-made set of materials that the community can use, the community which is broadly working in the area of resilience. We already had a student poster competition yesterday with 19 posters, and we'll be announcing the first, second, and third place winners with grand cash prizes today at the banquet. Aldo was organizing the poster session. And the final one is to bring together NSF-funded researchers from these various communities who are funded under a diversity of programs and probably don't get to interact as much, to find out what are some of the common themes. In terms of numbers, the attendees, we have 25 external attendees. Some are going to be here later in the day. A couple are going to be here tomorrow. We have 28 Purdue faculty who are participating, and 28 postdoc students and staff who are participating. And in terms of the primary areas of interest that were indicated by the attendees, you see the breakdown in there. in terms of cyber physical, and socio-technical resilience. So the organizing center, a few words about our center. It's CRISP. You see the leadership team in there. This is a center that was started in October of 2017. It is funded through multiple federal grants and 5 private organizations and fairly generous seed grants from Purdue. This is 6 leadership team members, myself as the director, Milind and Jitesh as the associate director, and 3 trust leads, Felix in IoT, Nadia in civil infrastructures, and Aldo in optimization. And this includes 23 affiliate faculty members as of now, who span the various schools within the College of Engineering and Computer Science. So the CRISP Center was started with the objective of creating some scientific methods to analyze failure modes of infrastructures. And infrastructures is a very loaded term. It can mean many, many different things. And for our purposes, we are defining this as cyber infrastructure, cyber physical infrastructure, and socio-technical infrastructure. And along with the scientific methods, the goal is also to create certain engineering tools to systematically build in resilience in these various infrastructures. And I already mentioned what are the focus areas that we have for our center, which match well with the themes that we have here at the workshop. The leadership team comprises people from various schools within the College of Engineering. There are 3 of us from ECE, Jitesh from Mechanical Engineering, Nadia from Civil and ABE, Agriculture and Biological Engineering, and Aldo from Industrial Engineering. Our center also has educational and outreach mission, so provide accessible short learning modules on different aspects of system resilience, and to create certain exemplar prototypes that can be used to highlight the need for resilience as well as some of the latest research innovations. So we are going to have a YouTube channel with short modules, and then the goal is to have a resiliency challenge competition where you stand up a cyber physical model system, see how resilient it is to various kinds of disruptions. So I'll very quickly cover 3 sample projects in CRISP, which covered cyber physical, and socio-technical. The first one is one that I lead on dependable embedded wireless network. So this fits within the cyber physical system resilience theme. So embedded wireless networks have fundamental resource constraints in terms of energy, bandwidth. The nodes are often untrusted. They may operate in disconnected mode, and you still want to do something usable out of them, something where there are critical functionalities which depend on them. And so far, the security and embedded world seem to be Twains apart. There have been many, many attacks, disruptions. In fact, the largest denial of service attack was created using a network of video cameras. So somewhat surprisingly to somebody outside of the field, many of the server level security protections that are available today are just absent in this embedded IoT world. So this project is looking at, can we systematically build in some of these protections so that the IoT world, embedded world, and the security world come closer together, and security becomes a first-class principle, just as energy is a first-class principle in building these systems. So there are 2 solution directions that are currently being explored. One is to use least privilege and randomization-based security. So this is joint work with Matthias Spar and a faculty member here in the center, Aniket Kate. And the second one is looking at game theoretic security, where if you cannot protect every asset in your system, how do you logically, systematically, formally define which assets you want to protect? And this is joint work with Shreyas Sundaram, another affiliate faculty member here. The second project I want to highlight is on socio-technical resilience theme, with Nadia being the PI for it. So this is looking at the role of transportation in the economic sustainability of a region, with some very influential results in the context of Indiana. So this work has developed a taxonomy of resilience as it applies to transportation and economic resilience, and it measures regional economic resilience and how that is tied to infrastructures like transportation, like energy infrastructure. And it provides a quantitative approach for assessing the association between these different infrastructures and economic resilience. And it provides a formally grounded econometric approach to analyze this kind of resilience. So this is too early in the day to get into all the equations, but I looked at this, and Nadia provided some speaker notes in there. So one of the interesting things that has come out of this work is you can identify what is the resilience of a state, broadly defined, as the economy goes through peaks and troughs. As disruptions happen in your infrastructure, how does it affect, on a short-term, medium-term, long-term basis, the economic resilience of your state? And very nice maps have come out to identify how resilient or not different counties in the state of Indiana are. The third project is in the cyber resilience theme, and Milind leads that project. So the objective is to create easy-to-debug programs, and yet these programs run efficiently on existing off-the-shelf hardware. So weak memory models have found a lot of favor because they're very efficient to run. However, they create programs which are very difficult to reason about. It's also too early in the day to look at code, so I'm going to skip that. But this kind of code, which apparently looks to be bug-free, because of the weak consistency model, can lead to crashes and null pointers. So weak memory models basically have led to programs which are very hard to debug. On the other hand, strong memory models are considered to be rather inefficient to execute on off-the-shelf hardware. And Milind's work is showing how you can bring these two Twains together, whereby you create memory models which are very efficient to execute, and yet you have easy to debug, easy to reason about programs. And this has been published in several of the top-tier conferences. So that's it with three just representative projects that we have going on in the center. In terms of the homework, or now what has become your classwork, we want to get your views in writing on the following questions. So this is the Purdue Qualtrics survey that we shared with you before you came here. There is a surprising number of responses already to it. We would want to hear from all of the attendees on this. As I said, this is going to form the seed for the vision articles that will come out of the workshop. And as you well know, these vision articles, they tend to be very influential. They're read by funding program managers, and they also tend to get very well cited. So we'll be publishing them at prestigious venues. So we want to get your view on what you think is the state of the art in one aspect of resilience to the theme that you are most interested in. What is the state of practice? What are the medium-term and long-term research and translational challenges that you see? And then what do you think are a few of the most promising technologies that are being developed, including probably in your lab, to address the third and fourth points? So then that's it from me. The next thing is we're going to hear from Melba, who's our Associate Dean for Research in the College of Engineering, with a few words about what the College of Engineering is up to.